Welcome back to codingcat.dev, where we give you cats the freshest dose of dev snacks. Brought to you by Cloudinary, build faster with AI-powered image and video APIs. Welcome back, Purrfect peeps. How's everybody doing today? We are talking all about LocalStack today, and if you haven't heard about it, we're going to break it all down kind of in the second piece of our podcast today. But first off, I want to welcome on, I should have asked you, and I did a terrible job at this, but is it Waldemar? Or
That's
is it
perfect,
W?
yeah.
Okay, so it's a W in there. All right.
Yeah.
Perfect. Awesome. Waldemar, can you tell the folks on the podcast kind of a little bit about your background and how you ended up at LocalStack?
Yeah, sure. So thanks so much for having me. So my name is Waldemar. I'm the CTO and co-founder of LocalStack. I'm originally from Austria, from Vienna, beautiful little country in Europe. Basically spent most of my career in software engineering, all the way from doing some university education almost like 10 years ago, and then working in different companies. One of the companies was called Atlassian, and this is actually where LocalStack, the first lines of code were written. So the idea was coming out of, we had a lot of AWS cloud usage, and we were kind of looking into novel ways to test the applications. And this is kind of how we started to develop this local cloud emulator, the first version of it, and then kind of took it public as an open source project. And yeah, it was kind of growing in the open source for a couple of years, and then 2.5 years ago, we started building a company around it, and that's where we are today.
That's really cool. So when you were at Atlassian, and even before that, you were kind of more like a team lead, if I'm LinkedIn stalking you correctly. Was that also, were you working on product at that time too?
So I joined Atlassian's data engineering team. So we were basically building some large-scale data analytics pipelines for all the product events and analytics. So basically, how is Jira Service Desk, Bitbucket, and all these other products performing? So it was basically a lot of huge files in S3 buckets and a lot of data crunching with Hadoop and this whole big data ecosystem. And that's really what brought us to also like a streaming-based, event-based architecture with Lambda and Kinesis and so on. And this is really where the first ideas for LocalStack came about.
And prior to that, like you worked at IBM as well, right?
Yeah, that's true. We've also been had a stint at IBM, worked there for about 2 years in the AI engineering department. So we're building essentially data pipelines for model training and inference. So I think it was about the time when, still today AI is really the number one thing, but also the whole DevOps and plumbing quote unquote aspect of it really became important back then. And sort of built some infrastructure to basically build your models and have inference on them.
Nice. And what programming languages were you writing?
Back then, it was a lot of it was written in Go, and today most of what we're doing is in Python. So
yeah, I was assuming you would have said Python originally, but Go back then. That's pretty cool.
Yeah, sure.
Have you ever found the need to kind of go to a lower level language at all when you're like maybe a Rust or like even deeper than that?
It really depends on the type of use case. Like certainly if you're working on some high performance backend applications where really throughput matters, and you want to have good distributed characteristics of the services, then things like Go or even Rust can be good choices. I guess for the work we're currently doing, Python's been a pretty good choice. It has some performance penalty for sure, but I think we've worked around that with quite some nice ways actually in LocalStack.
Yeah, I feel like the most I see people using Python is kind of around like the large language models and kind of everything surrounding that too. So that's really exciting to see.
Yeah, and there's a lot of innovation also in the Python ecosystem. Given how important the language has become, there's a lot of improvements in the interpreter coming up in new versions. Yeah.
Nice. So I think I really like to hear people's like stories as they progress through. And when you're in university, you actually have a PhD, right? Is that correct?
Yeah, that's right. So I spent sort of quite some time at university doing research on various topics related to cloud computing, software testing, reliability in general. So fun fact, like a lot of time I spent in my research days was on infrastructure as code tools like Chef or Puppet, for example,
Sure.
and just testing how these tools kind of converge to the target state under different testing scenarios and permutations and so on. So yeah, it's been some fun time, but I also enjoy like the problems we're working on today.
Was your intention to kind of stay as a teacher, getting your PhD, or what was the thoughts behind that?
Initially, yes, and like one of the benefits of doing research is really you get to travel a lot. It was
Yeah.
pre-COVID days, and we went to a lot of different conferences, and you can meet a lot of people from around the world. So that's really cool. Yeah, it really depends on what your career aspirations are. I think in academia you have a fairly narrow path towards what you can achieve. So
Yeah.
I think industry gives you some more opportunities there.
And is there anything in industry? Do you find you've learned a ton in industry, and will you end up thinking about going back and teaching again?
So I like the sort of scientific approach towards developing software, and also increasingly, basically, my job is also to build organization and scaling teams. So that part of it I still enjoy, and also, for example, we have this educational program where we give out licenses to university students,
Oh,
and also still do some lectures at university. But I would say more as a side gig, not as sort of my main profession. Yeah.
sure. One of my favorite classes that I took in university, it was during, was it early in my master's? I can't remember. It might have been in my undergraduate, but it was all about entrepreneurship and kind of they'd bring in CTOs from all around the local area to talk, and that was such an encouraging and like useful piece to it. Like we took all these finance classes and accounting classes and things like that, but at the end of the day, like why do I need to know these, right? Like I'm not going to become an accountant. I'm in computer science, and having those individuals like yourself as a CTO slash CEO these days, like there's so many aspects from that you need to take into those roles. It's unbelievable. So it'd be really cool to see you go back and kind of take everything you've learned and teach others about it.
100%. Yeah, absolutely.
Yeah. All right. Well, we're going to take a quick ad break, but Waldemar has some slides for us, and we're going to talk all about LocalStack when we get back.
Cloudinary allows you to remove any unwanted backgrounds, so you can reuse assets efficiently. You can also erase objects and people from images for placement in new experiences. For more engaging content, easily turn static images into dynamic animations, and rely on smart cropping to always deliver assets with a focus on the most relevant objects to your brand. Cloudinary Programmable Media. Build faster with AI-powered image and video APIs.
So I'm just getting back again, talking with Waldemar about localstack.cloud. I should probably put that in there in case people are searching for it. We're going to break it down a little more and kind of talk through LocalStack and what it's used for. From my personal experience, I've used a lot of Amplify on AWS, and I know the pains that surround that. They recently released Gen 2, which is a little less painful because it's letting you do some things that they probably wouldn't love, but it makes development quicker. So I'm really interested and eager to hear about LocalStack and how to kind of bring that developer experience onto my local machine so I don't have to push things out as fast. Where do you want to get started, Walmer?
Yeah, maybe you can just share a couple of slides to
Yeah.
set the stage, and then we can also dive into some demos. I always love to give live demos and see if things are going to work out well. So
I love it.
hope you can see my screen now. I'll just go into slide mode here. I mean, just to set the stage a bit, and by the way, feel free to jump in anytime, and then feel free to ask questions or additions. So basically, the context of where we operate in is cloud development today has certain challenges when it comes to the developer experience. So basically, there's lots of different resources to manage. Typically, when you develop something like a serverless application with a lot of, let's say, Lambda functions, DynamoDB tables, S3 buckets, and so on. So there's lots of moving parts in general. So developers end up deploying their changes quite frequently to the cloud, making sure that everything is working correctly, maybe having to make some local changes, uploading to the cloud again. So it's kind of a cycle of changes that are generally slowing people down. The other thing to consider is kind of remote debuggability of your CI builds, right? So for example, in this tile 4 here, if we assume that you have some CI pipelines running, some branches are passing, and then some builds are failing, it's sometimes hard to actually replicate the state onto your local machine and debug what was actually the reason behind a failing test. And then also, if you think about just things like developing in a sandbox environment, as is typically done in organizations, managing all these sandbox accounts for developers can become quite a lot of management overhead and also costly. So those are some of the challenges that we're addressing with LocalStack, and the community has sort of helped us shape this the story behind it. And basically,
I really struggle with that number 4 in there too, by the way.
You
I feel
do?
like it's constant, like issues with pipeline.
100%. Yeah, exactly. You have a failing test, right? And then trying to figure out based on the logs, either from your CI run or somewhere in the CloudWatch logs, for example, in the cloud. So it can become quite challenging.
Yeah.
And from a very like high level point of view, the solution, like imagine your application here, this blue box is moving through the different stages. Like you start on the local machine, then there's some kind of a CI/CD environment, and then all the way to the production environment. And the application is just basically talking to API endpoints. So in this case, I think this is Lambda, this is something like DynamoDB, this is probably S3. And the application is just talking to these APIs, and in the lower stages, it just happens to be talking to the LocalStack emulated endpoints, API endpoints that we provide. It's basically running in a Docker container. And again, the application is kind of agnostic of which environment it operates in. You can use the same code for production as you would use for local testing, but you have much quicker cycles of iteration with your application on the local machine. So this is really on a very high level, kind of what the solution brings. And one of the key aspects is speed, right? So when we think about developing applications and deploying these cloud resources, it really boils down to how fast can I spin up my resources. And we've done a bunch of comparisons here. It's obviously not a fully fair comparison to do like local versus a remote execution, because obviously local is inherently faster, but it can make a significant difference, right? So here, for example, we're looking at an RDS database that's spun up in LocalStack in 2 minutes or something, and then in the real cloud, it takes something like 20 plus minutes. And again, if you frequently deploy and test applications, and this is really what we want to foster with this solution, to really frequently test apps and also infrastructure code, then this can make quite a big difference for the developers.
Oh, yeah. Is
that something you've also experienced, like slow development times and deployment times?
Yeah. So for me, every time I'm touching, in Amplify, like it takes forever for CloudFormation to run, and there's a lot of checks that are occurring and like indexes it needs to work on. I haven't done a lot of RDS. Usually I go out to like the CDK to build that out, and it doesn't seem like it takes this long, but perhaps on the first load it does. So
yeah, absolutely. Cool. Yeah. So and this is really so one of the key pieces, and we'll get to a short demo to make this a bit more concrete, but one of the key pieces for us is we want to meet developers where they are today, right? So that's why we've developed a lot of different integrations, various CI/CD systems, for example, where you can natively run LocalStack. Essentially everything that allows you to spin up a Docker container is very likely to support LocalStack in CI. Different ISC tools, infrastructure as code, Terraform, I think is the most frequently used one, CDK, very much pushed by AWS as the cloud development kit, Pulumi, Crossplane, and others. And then all the way to different application development frameworks, test containers, which is a popular library to spin up local stacking from Java, for example. And I'm not sure if we have Amplify here, but there's also an integration that we've built for Amplify directly, which we can maybe check out. That
would be neat. Yeah, for sure.
Yeah.
I love Pulumi, by the way, like being able to stick within your own language and having like very similar power to Terraform. It's really cool.
Absolutely. Yeah, 100%. Pulumi has a pretty active community also, so we see a lot of uptake here in this area. Yeah, so why don't we just dive into like a short, quick demo and see the tool live in action. So basically what we prepared here is a small demo that has just a few parts here. So it's basically an S3 bucket notification sample where we have an S3 bucket that we're going to use to store some log files, just some JSON dumps basically. And whenever we put a file to this bucket, it's going to trigger a notification and call a Lambda function. And the Lambda function is going to do some processing on these log files. And then whenever we see certain, let's say, values in these log files, we trigger an alert to SQS, to a queue, and then another client can read off this queue to process these messages. So kind of a simple example, but just to kick things off a bit and see LocalStack in action. So what I'm going to do here is I'll just start LocalStack here. I just had a instance running, but I'll just restart from scratch here. It takes a second until it's shut down. Okay, so what I'm going to do is just do LocalStack start here. So this starts up LocalStack, and it's basically running in a Docker container, as I briefly mentioned before. So if we do a Docker PS here, we can actually see the container is running now. It's called LocalStack main. This is the image name, and it has a bunch of ports exposed basically.
And essentially, like right now, there's no services per se like running on this, right?
Yeah, so basically all the services are now available, up and running, but they haven't been loaded yet. So,
Gotcha.
so the entry point port 4566 is already listening, and the first request will basically enable the services and start them up. So what we can now do is we can interact with LocalStack with this AWS local CLI, which is a drop-in replacement for the AWS CLI, and just do an S3LS, for example, listing the buckets. There's currently nothing in there. So let me just create a bucket, which we're going to call test. And this has now been created. So this is kind of the most simple Hello World example that we can run. And you can see here in the debug logs, it's showing us list buckets, create bucket, and all these API calls that we're triggering from the local machine here. So this is kind of really just the basic setup. And now taking a look at our example that we've just seen in the slides. So this is actually defined as a Terraform script. So let's briefly go into the main TF, which defines all the different components in here. So we have the S3 bucket to store our logs. We have the SQS queue here with some queue policy. We have the Lambda function itself. We're going to take a look at that in a second. So this is the Lambda that just does some processing on the logs. We have some IAM roles, just a typical boilerplate essentially, and then the bucket notification, which links the Lambda function to S3 object created events if we put a file to the S3 bucket. So this is really pretty much it. So now what we can do is we can go ahead and usually what you would do is you would run Terraform apply. But in this case, we again have a small wrapper script. It's called tflocal. Again, it's a drop-in replacement for Terraform. And we can now say tflocal apply. And it's now reading in this config file. We can say, yes, we want to deploy these changes. And now you can see already in the left-hand side, it starts a deployment loop, basically. And again, it's worth mentioning, at no point here we're talking to real AWS. It's all happening on the local machine. In fact, it could even be offline in that sense to work with LocalStack.
This is a good work for being on the airplane at this point.
100%. I mean, we both met at reInvent, if you remember, and actually on the way to reInvent, it was just finishing some demos on the plane. So it really does work even if you're offline, which is pretty cool.
And I know we're talking like specifically AWS and Terraform. Does LocalStack go out to like GCP or anything else as well?
Yeah, not at this point. So we get that question a lot. We do have Azure in our pipeline for next year, but there's just been so much depth that we could still work on in AWS.
AWS is massive.
It is quite massive, I'm sure. And we're still a small team. So, okay, so now this application is deployed, and let's just take a quick look at the Lambda function that I just mentioned before. So I have this here in my IDE. And this is just a simple Lambda function where with the well-known signature here with the handler, you get the event and the context. Let me just zoom in here a bit so make sure that everybody can read this. And essentially what we receive in the Lambda function is S3 bucket notifications, which have records in the event. And then basically what we do is we just loop over all the records, do some checks on the contents of those, and then trigger an alert in SQS, basically if the CPU value is higher than a certain percentage here, which is encoded in these JSON files. I guess it's mostly for demonstration purposes, so the actual logic of the Lambda is not that important, but let's just take a quick look at my run script here, which is my little cheat sheet. And I can now put one of these log files to the S3 buckets. And what you can see here on the left-hand side is actually triggering the Lambda function. And this might be a bit hard to read here, but basically we see something like hello world, for example. So this is the output from the actual Lambda function that just ran in a container on my local machine.
That's cool.
And one of the cool things is I want to just briefly showcase this, what we call hot swapping. So we can say dev 123, right? So we just make a change. I'm just saving the file. I'm not redeploying it. And then basically the next time around, we copy the file, it triggers the Lambda again, and we see it's basically immediately reflecting these changes here in the output.
That's awesome.
This is really one of the main things that we really advertise a lot. Having these quick cycles of iteration on your logic essentially locally.
Yeah, especially like one tiny bug that you didn't capture, and it takes like cycles of trying to push that up, fixing it, pushing it up, fixing it. Oh, it's so frustrating.
Yeah, it gets even worse. So with Lambdas, you have to create the zip file and upload it to the cloud and so on. I think it gets even worse with Docker images, right? Because then you need to rebuild the image, push it to an ECR, and then things can
at
get
that point, like your tests better be really good so you can catch them early in that pipeline. Otherwise, you're taking 20 minutes instead of 2 minutes type of thing, and now you're down to like 5 seconds making this change. So
100%, yeah. Cool. So this is really, and I think essentially we could even like receive the message from SQS here. Don't have to do this right now, but just to illustrate a bit what the end-to-end kind of workflow looks like with LocalStack. There's also a web application that we offer, which has a bunch of different features. So it has a usage dashboard where you can see some basic insights into how the instance has been used, like the current instance and the historical instances. We have what's called Stack Insights to give you like detailed telemetry of the different API calls that were happening in your CI pipeline, for example. There's so-called resource browsers, which we'll see in a second. It's basically a simplified version of the AWS console to browse the resources in your local stack instance, and then also some more insights into your CI builds. So why don't we just quickly switch over to the web app. So this is under app.localstack.cloud. This is my account here. You will see on the dashboard, you actually see these stacks. So stack is basically one instantiation of a LocalStack container. And we can already see here, that's the one that's currently running. And if I click on it, we can actually see the interactions that were happening with this particular container. So you get some quite detailed insights into what was happening in that particular container. There was some errors, actually, some success statuses. So this is kind of useful to get some basic insights about the container that's currently running.
And is the equivalent, like when we're talking about stacks, when you look at CloudFormation, is it the equivalent to that?
Yeah, it's a good point. It's there is some resemblance, some similarity, but it's a bit. So stacks are really more like instances in our terminology here. So yeah, you're right. CloudFormation stacks would be on a slightly different level of granularity, even though oftentimes a CloudFormation stack maps to one sort of instance of LocalStack that it gets deployed in. But it's slightly different notation here.
Okay.
Yeah. But I think one thing that's maybe also quite nice to show is this resource browser, as I briefly mentioned. So this will look quite familiar maybe to some folks in the audience. So here you can see all the different services that we provide. And here, for example, I can go to S3 and we can see the particular buckets that were created as part of the sample application. So for example, our log file that we created here. And yeah, it's an easy way to get some insights into what's running in your instance. And again, even though this is a hosted web application, it actually talks to the local container. So there's no interaction with a remote cloud system. We can go to Lambda here, for example, as well. Go to our example. I think we can even look at the log files here. Yeah, so we can actually see the timestamps that were processed in this log. So this is kind of useful and nice as well to get some additional debug information in a graphical user interface. Obviously not as powerful as the AWS console, but
I like this though. Like it's very clean. You don't have to take and jump 10 steps into something to try to figure it out.
Yeah, exactly. That's true. And I think the UI experience from the console is also constantly evolving. Like I keep getting these Do you want to try the new UI experience? Pop-ups and
It's funny because I feel like for years they neglected that experience, and now they're starting to, and it's massively better than it ever was.
Yeah, absolutely. It's much more unified also across the services. Yeah.
So I'm kind of curious, when you start to like solidify like this example, and you're like, I'm ready to go to production. What does that flow start to look like, or even better yet, like you're ready to go to staging to get it kind of tested before production?
Yeah, it's a great point. So, typically, most of the projects that also like we use this, as you can imagine, for our own dogfooding of our own AWS services and infrastructure. So typically, what you have is some kind of a test environment where, with maybe a Docker Compose file or some CI script that basically runs the same test that you run locally in a CI pipeline. So that's typically one of the steps. It's very easy to take your local test setup to CI. And in fact, maybe I can briefly show this here. We got this section here in the web UI, which is called CI projects. And this is actually the builds that we see from our own LocalStack platform. So we use this for our own dogfooding, essentially, to get, for each CI run that we run, you get the detailed logs from the LocalStack container, and then also some traces for the different tests that we're running. So in our particular case, we're using Python, so it's using PyTest as the test framework, and actually drill into the requests and responses that were happening as part of the CI build. And then once all these tests are passing, it's relatively easy to make the switch to production. So typically it's either like a Terraform apply. So you wouldn't use TF local, but the actual Terraform.
Sure.
Or maybe you do a CDK deploy, depending on what infrastructure as code you're using.
And how are you keeping the two in sync? Like when you do TF apply and then like TF local, is it everything but the data? It can kind of stay in sync with the infrastructure?
Yeah, that's a great point. So usually what we see a lot is that in CI builds, oftentimes the infrastructure gets created essentially from scratch. So you start from a clean instance, then maybe you have your Terraform script, everything gets deployed, you run your tests, tear everything down. In the real environment, it's typically you have incremental changes, right? So you add changes on top of existing states. And that's why we've developed a mechanism, and this is, I think, a good segue into Cloud Pods, which is literally the next slide here in my deck, which is basically a persistence mechanism. So Cloud Pods, and again, from a terminology point of view, this is not to be confused with Kubernetes pods. It has nothing to do with Kubernetes. It's basically a persistent, it's like a zip file in a nutshell, right?
Yep.
But what you can do with Cloud Pods is you can take a snapshot of the state at any point in time of execution of your LocalStack instance, store it to a server, and then later on inject the same state into a new instance. And this really allows you to do like these incremental changes and deploys to really see whether these delta changes are actually working as expected.
That's really cool. And then so you could pull down as like 6 different developers, you could pull down that state or that snapshot across any of them at any moment, right?
Yes, exactly. So it's really extremely useful for sort of collaboration purposes. We see a lot of teams essentially when a new developer gets onboarded, they get the laptop, they check out a Git repo, and they set up their dev environment. And the first thing they do is they inject the state into their LocalStack instance to get up and running immediately from the state that everyone else is using. And this is extremely powerful for collaboration purposes. So in fact, if we want to take a quick look at how this works, so let's tear this down. Let's just restart LocalStack here for a sec. And so basically the way to interact with the Cloud Pods is via the CLI. There's also a UI component, but CLI is kind of the preferred way to do it. Now, first of all, let's just create, again, like a bucket. Maybe let's create an SQS queue. Let's do something like AWS local SQS create queue. I think let's go pass a queue name. Oops.
You can click hide on that thing if it's bugging you.
Yeah, that's good. Thanks. Yeah. Oops. Right. Queue name Q1. Okay, so we just created some simple state here. And now what we can do is we can run a save operation. I already have this in my history here. We can just say LocalStack pod save, and then we say test pod, or just any arbitrary name here. And what happens now basically, oops, okay, interesting. Probably gotta log in first. Log in. Just a sec here. I think it might even be already logged in up here. Let me just use the.
And I'm noticing, like, while you're creating these, it looks like US East 1 is in there. Are you just kind of specifying a random region, or are you actually using regions across?
Yeah, so we do have full support for like the different regions and also actually multi-account in LocalStack. US East 1 just happens to be, I think, the default in my profile, presumably.
Sure.
Yeah.
Is there like any sort of, I know this is getting super weird, but like slow it down if it's coming from like Germany so we can test that sort of relationship?
Oh yeah, that's a great. So this is actually the next point I had right after the cloud pod. So
Cool.
just yeah, bear with me for a second.
Yep.
So what I'm basically doing, so we start the cloud pod under this name here. What I'm just gonna do is restart LocalStack, and basically if you do another ls here on the S3 buckets, for example, it's empty as expected, right? Because the state is ephemeral. If you do a list queues, there's nothing in there. And now we can basically do the reverse operation, which is LocalStack pod loads. And this was the name of the pod, test pod. And this is basically now loading the same state back in, and we can then do the listing of the queues, of the buckets, and you can see that everything was basically within a second recreated from what we saved previously.
Nice.
Yeah, it's kind of something that our users are quite excited about, and enables us to do quite novel ways of collaboration and also dealing with state in a very flexible way, essentially.
That's really cool. So do you end up taking a branch and creating that state, like that pod can exist in a specific branch, or how do you actually pull that typically?
Yeah, it's a great point. So first of all, these pods are versioned. So here we created version 3 because I already created some previous versions of that same pod. So you can basically version these pods over time. In fact, if we go to our web UI, we would also be able to see this particular pod, which is created. What was it called? Test pod. It's got a bunch of different test pods in here already. Yeah, this was the one. And then we can see, okay, we got 3 versions of this created, right?
Gotcha. Okay.
And then the other thing is you can actually combine these pods together. So assume you have, let's say, some infrastructure with some, basic networking, EC2, VPCs, and all that.
Sure.
Then maybe some platform resources and then some application resources. You can actually combine these pods together and have the union of all the states in your local state instance.
Oh, that's cool.
So that's another useful thing to have. Okay, since you already mentioned before briefly, so one of the really interesting points that we've spent quite some time on is fault injection and simulation of, for example, error conditions, but also latencies, as you mentioned, for example, right? So so LocalStack is very configurable, so we can essentially inject any kind of fault situation, as you can imagine, much easier than for a cloud provider, right? It's relatively hard for AWS to say, I don't know, my entire region goes down, but for us, it's just basically a configuration that we can set in the emulator.
Yeah.
And the same goes for latencies and different error conditions and so on. So this is something where we can really help teams to make kind of resilience testing and make sure that their application can react to certain situations. For example, if a service goes down or if there's certain rate limiting errors and so on. So we have, in fact, a small UI that also features this chaos engineering. So I want to just briefly show this. So we have different kind of errors that we can inject here directly from the UI. And one of the cool ones is this region unavailable. So since you already mentioned regions before, we can now say, now let's just start an experiment and say that US East 1 goes down, right? And just click this button here and say,
And
start
3/4 of the internet has shut down at this point.
Yeah, right, that's true. I mean, you would say, you would think that this doesn't really happen, but it does happen. If you remember a couple of months ago, actually Lambda US East did go down. And now what we're seeing, we're trying to access that region and it's giving us some internal errors that are just generated by LocalStack. And after a couple of retries, it fails. If I go to US East 2, for example, that one's up and running and works. And then we can even go back and stop the experiment and then go back to US East 1 again, and it should be up and running. So this is something where we see increasingly teams are starting to run their CI tests when like sprinkling, with a certain probability, sprinkling some errors into the environment to just see how the application reacts to that, and making sure that you have fallbacks in place, dead letter queues, and all these different mechanisms for disaster recovery, essentially.
I assume they're able to trigger all of this via API too, so they can kind of do some CI testing to hit all of their different marks.
Yeah, 100%. So in fact, AWS itself has an API that's called the FIS, the Fault Injection Simulator, and we also sort of implement that API surface. And we even go beyond that with a so-called extension. So this is actually maybe a nice segue into extensions. So extensions is basically plugins for LocalStack, if you will. So you can essentially add additional services, emulators, and additional functionality. And we've built this outage extension here, as we call it. And this is a highly configurable chaos engineering system that's also configurable via an API interface, as you mentioned. So you can really enable that in your CI build.
Nice. That's really cool.
Yeah. So that's something that's been quite exciting, especially like the UI feature is something that we showed this at reInvent at the booth, and people were quite, oh wow, this is pretty cool. It's relatively hard to test these situations in the real cloud for obvious reasons. Another interesting, and we're kind of really browsing through the different features here, but another interesting point is IAM, so Identity and Access Management. So one thing we realized in LocalStack, so in the early days of development, there was basically no IAM enforcement happening in LocalStack. So it was a permit all system. You could do any operation and just feel free to go. And then once you make the switch to production, you end up having maybe some issues with policies and some lacking permissions and so on. That's why in newer versions of LocalStack, we actually have built an IAM enforcement engine. So you can actually simulate policies and access restrictions and so on. And one of the cool things is it doesn't only generate it doesn't only enforce policies, but you can actually also generate policies by observing the requests that are being made to LocalStack. So we have this again. It's something that we've exposed in the UI, and we can enable what we call the IAM policy stream. So once this one is enabled, LocalStack basically now starts listening for any interactions with the system. So we do a list function here, we list the buckets. And if I switch back to the UI, it actually shows me these are the particular permissions that are required to run these operations that I just ran, right?
That's really nice.
And you can really easily copy paste this into your policy editor, for example. If we ran this for our sample from before, you would see a very long policy coming out of this because we have all sorts of moving parts, SQS, S3, and so on. And this is really useful from a debugging perspective as well, because if you have a permission denied situation, basically you will get some detailed logs also in the LocalStack log. It tells you exactly, I don't know, this Lambda function cannot access this DynamoDB table because some policy is missing, for example.
Yeah. When I'm running an Amplify, I feel like I'll run into an issue like this, and it's like one error at a time that I get to go through. Like, oh, you fixed that one, but now I can't do this, and now it's on to the next one. It's like everlasting until I can get them all gone.
Absolutely, yeah, 100%. And the other cool thing is also we're working on a mechanism for like basically minimal policies, because what you see here, for example, is a star resource, and usually want to narrow it down as much as possible.
I had a client that was quite the stickler once on just like specific, and I'm like, your policy is ginormous now. Like it's to the point where like we're gonna have to do something else. But it is to each their own, I guess.
Yeah.
when you're like listing out functions and you have 98% of them, like, is a star gonna be okay? I feel like yes.
Yeah, it's definitely a trade-off. Yeah, for sure. It's a good point.
Yeah. Anyways, yes, this is great. What do you have next?
I mean, I guess we've been going through, briefly talked about extensions, which again is a pretty cool way to extend LocalStack functionality. I think we also covered this debugging with CI builds. So we already briefly looked into the web UI, where you can actually see what's happening in my CI build and the different interactions. Maybe just one more point that's quite interesting that we recently put out there as a preview is ephemeral instances of LocalStack. So the way this works, or the idea basically being, the main use case for using LocalStack is basically on your local machine in a Docker container, as we just did. But there's also some cases where you maybe want to have like a shared instance that can be viewed by others. For example, if you're working on some kind of a UI application, web application, and you have like maybe a pull request with some changes, and actually creating a preview that allows other team members to review the changes in the in the web application. So we've created this this new mechanism here for creating ephemeral instances, as we call them. And you can basically say, create a new instance here. And what's happening now in the background, it's actually spinning up a small cloud VM, basically a container, runs LocalStack, and we should get back in a couple of seconds an endpoint that we can then use to interact with that LocalStack instance. So it's, again, like a very easy way to spin up an instance real quick, work with it, and then tear it down again after we don't need it anymore. So what I can do here is set, let's go AWS endpoint URL. So this is the environment variable, and then I can say locus s3ls. Let me actually shut down LocalStack here just for the demo effect. And I'm running an S3 command here, and this is really going against the remote instance. I can create a bucket here, and again, you'll just see these warnings, but I think they can be ignored. It's just for some SSL connectivity. But now we actually have an instance that we can interact with remotely without having to run Docker on our local machine, right?
Oh, gotcha. Okay.
Yeah, that's something that we're quite excited about and want to get some more feedback on by the community. It's currently in alpha state, but looking forward to building it out more with the community.
Yeah, that's really cool. I'm kind of curious. So we mentioned Atlassian early on. Is there still a relationship there, or is like LocalStack all privately funded? What does that representation look like?
Yeah, so there's no more relationship to Atlassian whatsoever. So essentially, the point in time when we took the project open source under the Apache license, that's basically when it became an independent open source project. We are now privately funded. That's correct. And I guess we've been flying a bit under the radar and haven't really done much of an announcement around this yet, but certainly can share more in the next year.
Cool. Yeah, that sounds great. Well, thank you for showing me all about LocalStack. I think it's immensely successful even at the point it's at because of how fast developers can kind of get up and get through AWS and all the issues surrounding AWS. As we know, it's kind of this massive beast, but to be able to develop quickly locally, I think is amazing. So that's awesome.
Thanks.
We're gonna change gears a little bit and go into what we call our Purrfect Picks. And you shared a game with me for your perfect pick. Are you ready to talk all about it?
Yeah, absolutely. I mean, this is just something that came up recently. Somebody from our team posted this little game here in one of our Slack channels, and I guess we just became quite addicted playing this. And it's almost like an internal competition who's got more points. So it's like a really simple game, essentially similar to something like a bit similar to like Tetris, essentially. So you just have like all these fruits falling down, and then they kind of grow in size, and then you have to make sure that you get as many points as possible, and they basically grow into much larger fruits over time. So yeah, it's really fun and something for the holidays that we've spent quite some time on in the last couple of days playing this game.
This is pretty wild. I wonder if this is WebGL or if it's actually like CSS under the hood. I'll have to check that out later. That's pretty crazy.
Yeah, I think there's also a PlayStation version of this, so it's I don't know, it's become quite popular, I guess, in the meantime. Simple but
That's
effective.
interesting. So is it Suika game?
Yeah, Suika.
Suika
Yeah.
game. That's cool. I like it. My perfect pick is Kyber.ai. So I think it's somewhat becoming popular now, but because of, let me see if I can find it. I can't. Maybe it's in the gallery. There's an edition of this, or there's a music video that was created, and I can't think of the band for the life of me right now. Anyways, this is really cool because you can put in different styles. So you can put in an image. So a lot of people have been taking and like using ChatGPT to find the perfect image they want to start with, and then they feed the image in. The other way to do it is through audio and video. So I did a lot of different things with the audio and uploaded them, And for Christmas, I put together a little Christmas album using Kyber, where I tell it like these crazy stories, and it actually makes a full video from them. And it's got our just kind of Christmas music that plays in the background for like when you're hanging out for the holidays. It's got some trippy stuff. So I had put a cat chasing a mouse, and what it ended up doing was taking cats that turn into mice, which become a little interesting and weird. So I left it because I thought it was pretty sweet. But it takes amazing stories and like flip books. The one thing I'm noticing over and over with AI generation is it's not doing well with words. So like this gets a little weird and things like that. But it's come a long ways. And if you watch, like the beat of the music goes through. So shout out to John over at Supabase who showed me their album. It's amazingly better. It took John 2 years, I think he said, to write the music for theirs and dive into the AI video generation later on. So super cool stuff. Thank you so much for joining me, Waldemar. And I really appreciate you showing off LocalStack, and huge success in the future, man. It looks really cool.
Thanks so much for having me. It was a pleasure.
All right. We'll see y'all next time.